Now let's look at another kind of question, or a slightly difficult question. So this kind of question requires substitution, and I'll kind of show you why it needs substitution. So let's take a look. So the question says find y double prime. That means we need to find the second derivative of x to the fourth, y to the fourth equals 16. All right, let's go ahead and find the first derivative. So go ahead and pause the video and then find the first derivative. All right, pretty easy. So dy dx is negative x cubed over y cubed. We're going to find the second derivative, which means we need to do this one more time. So it's probably better if you actually bring that y cubed up into a y to the negative 3, so it's easy. So we are trying to find the second derivative, so that's pretty easy. We just need to take another derivative. And so if we recall kind of the notation for writing second derivative is d2y dx 2 squared, like that. So basically we're saying take the derivative of the left hand side and right hand side. So left hand side becomes this. Right hand side we need to do another implicit. This requires a product rule, so negative x cubed times negative 3 y to the negative 4 dy dx plus y to the negative 3 negative 3x squared. All right, now we're going to simplify this as much as possible. Sorry, not negative, positive. 3x cubed y to the negative 4 dy dx minus 3x squared y to the negative 2. Sorry, I meant negative 3. Now, what do I mean by requiring substitution? So you see here, dy dx is kind of part of the derivative for our second derivative, and that doesn't really make any sense if you were to actually figure out the value for the second derivative, then you have this kind of dy dx in a way. So what you want to do is now use substitution. So we know that dy dx is equal to this. And so we're going to take this and substitute into this dy dx, just so that everything is in terms of x and y, and there is no dy dx in the answer. All right, so let's do that. 3x cubed y to the negative 4. And then substitute negative x cubed y to the negative 3, and then minus 3x squared y to the negative 3. All right, let's simplify as much as we can. So negative 3x to the 6, y to the negative 7, minus 3x squared y to the negative 3. All right, so let me put it over or change it so that there is a denominator. Sometimes it's easier to see. All right, it looks like if I wanted to combine them, I need this to be the 7th. At this time, you can simplify some more if you want, which is in the numerator, you can take out a negative 3x squared. So then you get x to the 4th plus y to the 4th. Okay, that should be as much as we can simplify. All right, so let's have you practice this. So find y double prime if this is the equation. So go ahead and try it. Remember, you need to substitute back first derivative of y so that you can have everything in terms of x and y without another variable. All right, go ahead and take a look at your answer. So first take the derivative from both sides. You get dy dx equals 3 minus 2x over 2y. And then take the derivative again I use quotient rule, but don't forget that there is a derivative inside y. and then you want to substitute back, and then just be careful of the algebra part. All right, now that we know how to find the second derivative, same thing as before, we're going to go through tangent equations, find the value, our horizontal tangent, all that stuff. So, but this time it's just, a little bit harder because we have implicit. Okay, so let's take a look at this question. So you have this equation, you're going to find y double prime at the point where x is 1. So this is kind of the same drill, but then now that they want you to find something, so then there are some tricks on how to do it quickly. All right, so let's go ahead and have you find, let's see, let's have you find the second derivative. But once you get to the second derivative where, when you find the second derivative for this one, you're gonna have to use a quotient rule. Once you write the quotient rule, please stop right there and then play the video. All right, at this point, you want to stop because there's a trick to this problem. So this problem says find a value at x equals 1. When they want you to find a value, what you want to do is, kind of do the easiest thing possible, which is evaluate as soon as you can. You don't want to simplify the derivative anymore because when you simplify, there are a lot of possibilities that you're going to make mistakes, so we don't want to simplify. Okay, we just want to find out what the second derivative is. So at this point, we want to substitute in everything we know in here so that we just want to find a value. All right, so if you look at this whole kind of second derivative is kind of messy. You need an x, which we know is 1. We need y, which we don't know at this time. We need dy dx, which if you look back, also requires x and y. So the important thing is we need y. And how do I find y? Well, let's think about it. How do we always find y? We plug it into the equation. So the equation says, I'm going to change different color and write it here. This is the equation. We want it at x equals 1. So we need to put in x equals 1 and solve for y. So 1 squared is 1 plus 1 times y is y plus y cubed is 1. So that 1 cancels. So I'm going to put this in the correct order of polynomial. Y cubed plus y equals 0. So this is just factor and solve. So y is equal to 0, or y squared plus 1 is equal to 0. Y equals 0, that's just, that's it. Y squared plus 1 equals 0 is going to end up with an imaginary number, so it's not going to show up on the graph, so we don't care about it. So y equals 0. All right, that's great. So now, since y is equal to 0, we're going to evaluate the first derivative with that information. So negative 2 times 1 minus 0 over 1 plus 3 times 0 squared. And that's pretty easy, so it's negative 2. Now that we know y is negative 2, we're going, dy dx is negative 2, we're going to substitute in everything. This saves a lot of time from you simplifying and then plugging in the values. So 1 plus 3 times 0 squared times negative 2 minus 2 minus negative 2 times 1 minus 0 times 1 plus 6 times, I'm sorry, I forgot what, y is 0, and then dy dx is negative 2, all over 1 plus 3 times 0 squared. All right, let's look at which ones are going to end up 0, so we don't have to care. This one's going to be 0, so that makes the whole thing 0. Let's see. I think that's all we can simplify. This part is a negative 2, so negative 2 times this part is 0, so 1 over 1 squared. So this is 2. So much easier if you evaluate as you go. All right, let's have you practice. Find all the points in the first quadrant where the tangent line to x cubed plus y cubed equals 6xy is vertical. Vertical. What does tangent line is vertical mean? Right? So if you have a graph like this, where is the tangent line vertical? That is here, right? The tangent line is vertical. Now, what does that actually imply? That implies that the derivative is undefined. So if you want to figure out where the tangent is vertical, you have to take the derivative and then figure out where the derivative is undefined. All right, so that means you don't need second derivative, you just need the first derivative. So let's go ahead and have you find the derivative, and then let's come back and solve this one together. All right, we got to the first derivative. So the question is, where is the line, the tangent line, vertical? So how do we make this derivative undefined is really the question. How do we make it undefined? Well, to make it undefined, the denominator has to be 0. So we need to make the denominator 0. All right, well, now what? So what we're going to do now is solve one variable in terms of the other, kind of like what we had done before. So I'm going to add the 6x on both sides and then divide by 6. Right. 6y squared over 2 is x. So then now what? Now that we know that there is this ratio to x and y, what we're going to do is plug it back into the original equation and then attempt to figure out where x and y are. The original equation, if you recall, is this one. So we're going to plug it back in. So every x is equal to y squared over 2. So we're going to substitute in that information to all the x's. So I'm going to do it here. So x cubed plus y cubed becomes y squared over 2 cubed plus y cubed equals 6 times y squared over 2y. All right, simplifying that. Y squared cubed is y to the 6 over 8 plus y cubed, and the 6 and 2 cancel, so it's 3, equals 3y cubed. All right, this looks like a very complicated thing to solve, but you remember this is just kind of the same thing you've been practicing from Algebra 2, which is make the equation equal to 0 and solve. So let's do that. Y to the 6 over 8. And I'm going to subtract 3y cubed on both sides, so minus 2y cubed equals 0. And remember that we don't like fractions, so multiply everything by 8 to get rid of the fractions. So y to the 6 minus 16 y cubed is equal to 0. All right, again, when the equation is equal to 0, all you really need to do is factor and solve. So take out the y cubed. All right, so now make each factor equal to 0. So y cubed is equal to 0, or y cubed minus 16 is equal to 0. Y cubed is equal to 0, it's just 0. This one, y cubed is equal to 16, so then y is equal to cube root of 16. All right. Now at this point, we need to actually figure out the point, right? Because that's what the question is saying. Find all the points. So we only found a y value. We need to actually find a point. And so now the question is, how do I find the x value to this y? Again, plug it back into the equation. Now the key here is first quadrant. So this y equals 0 is actually not on the first quadrant. Y equals 0 is on the y equals 0 is on the x-axis. So that's not what we want. We want this one that says y equals cube root 16. All right, so now let's plug it back in. So let's plug it back into the equation. So equation is x cubed plus y cubed equals 6xy. So let's plug it in to figure out what x is equal to. X cubed plus cube root 16 cubed is equal to 6x times cube root 16. X cubed plus 16 is equal to 6 cube root 16x. All right, so this one you can probably solve. I mean, there are many different ways to solve, but one way that might be easier for you is just to graph it. So x cubed minus 6 cube root 16x plus 16 equals 0. So then what you need to do is plug this into the graphing calculator and then figure out where it's equal to 0. That means where it hits the x-axis. Once you do that, you're going to get 3.175. I'm sorry. So then the point where there is a vertical tangent line is cube root 16, 3.175.